Well, hi guys, Emma again. Thanks for tuning in. This is part 6, I think this time we'll get it right. And the second part in making the crank for this little oscillating engine. I've screwed up a bit and I've managed to reformat a video card. It was unintentional, so pretty basically we've missed some parts of our video, but I'm going to do the setups again and we'll have a bit of a look and go over what I've already done just quickly. When we finished last time, we had this crank web, Loctited on the crank, and just the discs Loctited on the crank. And first job is to true it up that way and that way. So we've cleaned that up, and we'll just break the edge with the diamond file. Probably not a bad idea to clean that up anyway. And the next job was to mark the PCD. I've already drilled this here, and you'll see in a minute how I've done that. But the next job was to set this just right at the edge, and just feel it scrape, and then wind it in. The PCD is, or the pitch circle diameter for the crank pin is 16mm, so that's an 8mm radius, the drawing says, and the crank pin's 24mm outside. So all we did was set that up, and we used our dial to measure in exactly 4mm, which is the difference, and marked a circle. Then I center punched it. So I've set this crank up in the 4-jaw now that it's Loctited in nicely. That's the last job we did. I've just set it up within a couple of thou there with a center and a clock. The most important thing here is that it is nice and square, and that's pretty easy. Just use a piece of flat stock over the top. When you center punch this, don't forget, dress the top of it up with a diamond file or something, just so that you don't get a bump when you're trying to set it up nice and square. So that's what I've done, and I'm going to take this off. Slip this out, and we're going to drill in with a center drill. Always make sure that nothing's going to interrupt or bang on anything. That's important, or you'll break a tool or worse. Nice sharp new center drill all the time. Oh well, if you do have an accident with it, you'll know, and then it's time to get a new one. Don't mess around with them. Just chuck the old one out. It's easy to say, hey, save it. You might use it for a boring bar tool or something sometime. Never happens. It might for you, but you're always tempted to use one, and then you get rubbing and you get something not on center, and you regret it afterwards. So it's not a bad idea to throw them out when they get blunt. Now, I have made these with a threaded pin in the past, and that's quite a good idea. So just thread him M3 and thread the pin, but they need Loctite on them anyway, so there's not a lot of point in it. It's probably best just to drill him to a nice neat fit, or to ream him if you can, and push the pin in and Loctite it. That's going to be plenty good enough, and it's going to be just as good as a threaded one, and it's a lot less angst and a lot less problems, and you're more likely to get it right. So that's what I'm going to do. So I've got a 1/8 D bit there, it's 325, and it looks to be in pretty good condition. I don't think anyone's used it actually. That one looks good. So what I'm going to do is just drill it 3mm. I'm going to use a 1/8 pin. The fits and parallelity are probably much more important than than actually getting things to the size the drawing says. We've said that before. Now for some reason that 3mm drill in there is actually 3.2. So I don't know why anyone would do that. D-bit we're going to put through. And that's cutting beautifully. A little bit of oil on that. And we should have a beautiful 1/8 to size hole. And that's that job done. We can slip him out of the chuck. There we go, that's the crank pin hole. It's got a little burr on the inside. We'll give that a clean up with a drill bit. Or the centre drill bit. And a rub with a diamond file. These are good because they've got a safety edge. You don't want to be hitting that with a file and putting a flat spot on your crank. So the next job is to put that thread on the end there. It's just an M5 thread. They're pretty straightforward. We should have it already machined down to width. I'm going to make a confession here and say that I only had it machined down to 5.5 and it was a little bit coarse. So when I tried to thread it, it stripped a bit. And I've had to remachine it and shorten that taper up a bit. That's not going to matter very much, but that's what's happened. We've got a reasonable thread, but we've got a piece sticking out on the end there, which isn't going to worry anything either. It's look fairly neat. So I set that up in the 3-jaw and just threaded it with a button die up against the drill chuck until I got it started and put the centre back in, and that worked fairly well. Don't put too much strain on it because your Loctite might let go, but if it's had time to cure it shouldn't be an issue. So that's what I've done. I've just found a 5mm nut. We still need a washer for that, which is a pretty straightforward bit of turning. So the washer's pretty straightforward. I've just used this bit of same stuff that I use for the crank pin. I'm just going to machine that up. Face it off nice and square. And I've had a bit of a look at the crank, and I reckon it's probably about 15mm would be a really good size for a washer. Doesn't want to be any smaller or any bigger. That'll look about right. And sometimes if it looks about right, that's good enough. It only wants to be a couple of millimetres thick. And it only wants to be a couple of millimetres thick. So have a look around and see what you can find. Probably just a 5mm washer would be nice, but it really wants a bit of a chamfer on one corner, on the outside corner. And it wants to fit on the crank a bit too, so So I've chamfered that a bit on the corner just to make it look nice, and I've machined it out with it. I've just used another D bit there. These are well worth having. I've said that before and I'll say it again, they're the best thing to have in a home workshop. You can do a lot of good work with tools like that. They are a bit old-fashioned, but old-fashioned tools are always good. It's very easy to fall into the trap of always wanting the latest and the greatest, and the carbide end mills, etc, etc, etc. And yes, they're quick and they do good work too, but you really can't beat old-fashioned tools like this, and I've got quite a collection of them, and they do tend to get used, so look out for them, especially at flea markets and the garage sales. And even if you're not sure what they are, bring them home and have a bit of a look at them. I guess these were probably made, a lot of these were made for production work and factory work where everything had to be spot on and on centre. And they are out there, they turn up on eBay and they turn up in clearance sales and things. They're well worth chasing up, so they're a really good tool, and that's what I've done there. So now I'm going to set the parting tool up and part that off, and we're going to give the back of it a bit of a lap with a file, and we'll set it up again and machine it, and that's that part done as well. So next job, I've set that parting tool up and sharpened it. I've noticed we're getting a bit of belt slip on one of these flat belts. Time to shorten it up a bit, and I'll do that probably directly, but right now we'll just worry through this. That's a pretty ugly parting off job because that tool wasn't quite right, but it's cut it all right. Now I've just got a couple of bits of tool steel there, and I'm going to use them as parallels to set that up. They're always useful for parallels if you can find it, especially if you find match sets. The thing about tool steel for parallels is that they're never ever the same both ways, so mic them up and mark them so that they are the same. One way is different to the other usually. It's not very much, but it's just a little bit. You can feel that ridge there if you look at it. Just be aware of that if you're going to use them as parallels, but they are really good for that if you've got a couple of nice new bits. So there we go, that's set up. Next job is to change the tool back over and to machine that down nice and square on the back. And that looks like it needs a little bit of a and on the same setting there, I've just run the original D bit through just to put a little bit of relief on the back so that it screws up tight on the flywheel rather than the washer. And we'll slip him out and give him a dress up. Same thing, just to break all the edges so you don't cut your finger. And that's the retaining washer. So the only job left to do with this is to find a 1/8 drill and to Loctite in there and cut him off and polish him. and the crank's finished. So that's the crank in, with the washer and the nut on the end and the taper. So the last part of making the crank is to find a crank pin. I just went and got a couple of cheapy drills. They're not cheapy drills, they're good quality. But these are number 30, which are a good fit in a 1/8 reamed hole. That's the pop rivet drill size for 1/8. If we have a look there, that's quite a nice fit there, and it should be a good running fit if we make if we Loctite it in this side and make the gudgeon hole the same size. So I'm going to mark that at 16mm is how long it's got to be, and just slice him off the Dremel quickly, and we're going to put him in the chuck and clean him up with a diamond file, and hopefully we should have a crank pin that's ready to go. So there we go, that's the crank pin kind of cut off, not particularly neatly. The back end really doesn't matter very much because it does go into the crank disc and it's out of sight. Fraction short's probably better than a fraction long, although if you can get it right to size, it's as good as anything. So if we do that up in the 3 jaw and start this up, sorry about the VFD whistle, those that have problems with it. I'm using that diamond file. Again, that's going to take nearly no time at all to dress that up. And we turn him round with a nice square end and just give a bit of a clean up on the end. Take the sharp edge off, which isn't going to take very much either. And that bit was as easy as that. So there's our crank pin. Wants about 10mm sticking out, so I'm going to just give that a clean up. A little bit of Loctite primer, which is vicious, awful smelling stuff. It burns the back of the throat if you get it a bit close. And the crank the same. Then we're going to put a bit of just a bit of green Loctite and poke him in so that there's 10mm sticking out, and that's the crank pin done. So lid back on the Loctite, and thanks for watching, guys. That's the end of part 6, or part 5 and part 6, and the crank. Next we'll have a look at how I made the flywheel, and we're getting very close to being finished. Don't forget to subscribe, and really appreciate you tuning in. Thanks, guys.